হ্যালো, কেন? মা কোন বড় ফোনটা নিয়ে গেছে? ও, আমি তো ইয়ে করেছি, আমি তো অন্য ফোন, মাকে তো ছোট ফোনে ফোন।
Good afternoon. Am I audible?
Yes, sir, audible.
Thank you. Nidban was asking for me. I am Shankar Mukhopadhyay. Please tell him that I have joined. Thank you.
Okay, sir.
Hello, Shreya. Hello.
Yes, ma'am. Yes,
You can
ma'am.
start it. You can start.
Okay, ma'am. Okay, ma'am. 1 minute. Okay. Good evening to everyone present here. I hope everyone is doing well in the course of this pandemic where we have been constantly fighting to survive. Today, on the 1st of September 2021, I, Shreya Datta, a student of EEE Department of IEM and a member of IET.
I, Shomo Ghosh, a student of EEE Department of IEM and a member of IET,
have gotten the opportunity to conduct this webinar on role of battery storage towards sustainable transportation, challenges and mitigation.
Firstly, I would like to introduce Mr. Shankar Nath Mukhopadhyay, Chairman of Kolkata Local Network, a graduate in electrical engineering of Jadavpur University of 1983 and who has above 30 years of experience in power sector, worked in GEC, Tata Power and CSC Limited. He has experience in operation and maintenance of generation and distribution of electricity. He also has expertise in power system operations, load flow, and load dispatch, and efficiency improvement in power utility. He has also had experience in load forecasting, network planning, and techno-commercial functions in power business. Since last 10 years, he is heading the Asia Institute of Power Management, the training and consulting unit of CESC Limited, and played a key role in expanding the institute all over India and abroad. He has proven expertise in business development, in distribution business, and franchises operations. He is a chartered engineer of the European Council, the chairman of the Institute of Engineers and Technologists (IET), and an energy auditor. He is also a faculty of Jadavpur University on Power Systems in Power Engineering Department and executive member of Energy and Environment Committee of the CII and Bengal Chamber of Commerce. Sir, we would like you to share your thoughts on the webinar.
Good evening, Shoma. Thank you for your kind words. Uh, I feel honored to be here and extend my heartfelt thanks to you and all the seniors present here. My love, affection to all my junior friends who are still in college, and I do expect that each of you will have a very successful, bright career in future. The topic today is very, very contextual and important if we see the topic in the light of sustainability. Sustainability is something which requires a deep understanding, and perhaps the word doesn't carry much value when a person is young. But sustainability means that in the green world where we are living with all other living planets, all other living animals, flora, fauna, everything, and all these things are constituting the planet where we are breathing, where we are surviving, where we are having our entire livelihood, emotions, and working periphery. The world, if it doesn't remain what it is like today, then what will happen to mankind? What will happen to all of us? The old, young, and the people who have not seen, who are coming in the earth as a new generation. So, if we want to sustain ourselves, the human society, we must be very vigilant and cautious. The entire environment should be congenial to it. We are doing so many activities against the nature, and today the nature is basically, taking its revenge. It's not revenge, it is the natural outcome. If you do something without any mercy to some even a neuter gender, the ultimate results, that is the shortage of resources and the predicaments of our activities, will come as an end result which will not be very palatable to us. What is going to happen? What I intend to tell? That today the scientists and engineers are really extremely cautious about the rise in temperature. We call it global warming. All you know, in 2015, Paris Accord, a decision was taken that the global temperature rise must be restricted. To what degree? That is maximum 2 degrees centigrade of rising can be allowed, that of pre-industrial period.
Yes.
And every objective has to be taken, every care has to be taken to restrict it even lesser, that is 1.5 degrees centigrade. People are working on it. Everyone is sincere, but there is a great but. We are far off from the target. We are far, far off from the target. In fact, perhaps if the present rate continues, by 2030-35, we will cross that limit. I don't know what will happen, because there are many things may take place which are not right for the society, not right for the world, not right for the human. What are the way outs? This is one side. The other side is, if we talk about India itself, we entirely dependent on coal, dependent on foreign countries for oil. All you
Yes,
know,
sir.
we import
Yes.
oil, which is around 80% of our total, and the money, which is a mind-boggling figure, 100,000 million Indian rupees are spent for importing this amount of oil. So in energy, we are insecure. In oil, every aspect, even today, we are importing a bulk amount. So when the industry will go further, when the energy demand will rise in future, I'm not going into these details, we will require much more oil. What is the
Yes.
respite? The government is trying to push electric vehicle as an alternative. Why electric vehicle? Because the electricity which is stored in battery, they can give support as an energy, which is supplementing the costly fuel, not only costly fuel, but also the carbon dioxide, CO2 or greenhouse generating fuel. So we are getting twofold benefits by electric vehicles, that we are getting the benefit of reducing CO2 emission, that is greenhouse gas emission. At the same time, we are reducing the costly import, costly foreign reserve, which will give us that benefit. But how the energy will be stored, where it will be stored, that should be stored in battery. And what are the battery components? Normally, the battery components are not these lead acid batteries, these are lithium-ion batteries. And the charge density, what is a very important parameter for a battery, that on that basis the researches are on, and the cost of lithium ion batteries are pretty high. So the cost of an electric vehicle is also high.
Yes.
Right now,
Yes, sir.
researches are going on how we can improve the charge density of lithium-ion batteries, so that in future this can be made more cheaper, so that mass penetration can be possible. This is one way. And the other way, which I also like you to think, that we should have a very clean charging and universally distributed charging infrastructure, so that the charge anxiety, that is the battery, whether it will go exhausted. So if it gets exhausted, where I'll be having a recharging facility, that is also a phenomenon which is impending the growth of this electric vehicle. So these two pronged approach we need. Number one, making the battery cheaper, where research is on, try to make this battery, lithium-ion batteries, cheaper, and making a good infrastructure of electric charging. So, as a whole, the discussion will be on battery today. I think in future, if you can make a discussion on this infrastructure, that will also be good for you. But
Yes.
I fully appreciate your objective of making this thing your workshop or your discussion target. I wish all success, and request students and all the participants to have a rapt attention on this topic. Here I end. I wish all the best to you. Thank you very much.
Thank you so much for enlightening us with your views, sir. Now, let's welcome Mr. Shushanta Ray, Secretary of IET Kolkata Local Network, who received his BE and ME degrees from Electrical Engineering Department, Jadavpur University, Kolkata, India, in 2002 and 2008 respectively. Presently, he is an assistant professor in the Electrical Engineering Department, Jadavpur University. Before joining Jadavpur University in 2009, he has worked as a scientist in Defense Research Development Laboratory, Hyderabad, one of the premier laboratories of DRDO India. He was a visiting professor of UPV, Spain in 2019. He received IEEE PES Outstanding Engineer Award in 2018. He is also Secretary of IET Kolkata Network and Secretary of IEEE PES Kolkata Section. His field of interest includes development of embedded systems, design of electrical machines, fault analysis of electrical machines, BLDC, motor drives, etc. We would like you to say a few words about the webinar, sir.
Thank you, Shreya. Thank you, other
Thank you.
volunteers present here in inauguration of this particular webinar, which is titled as the battery and its challenges in the transportation area. As you know that battery today is a very uh, important item for not only for transportation, for any kind of portable devices that we use in our day-to-day life,
Yes.
maybe your laptop or mobile phone or everywhere. Now, initially we thought that we'll have something where we can store the electricity. Okay, but that is not a uh, as my option. That is not a very good option to store the electricity, because as you know that electricity cannot be stored, and if we store, then that efficiency will go down. Okay, so the main purpose of applying means purpose of using the battery is basically portability. Okay, so due to that we can use anywhere, starting from a satellite in space, or maybe very close to our heart, that means in a space maker. Okay, so there also we need some
Yes.
sort of battery, and if the problem is for the pacemaker, we cannot recharge the battery. Then after 10 years or 12 years, we have to change the batteries, because the type of the batteries we use there, that is basically the primary batteries. Now batteries are two types, primary and secondary, and the secondary batteries, that is a rechargeable battery, and there are several examples like lithium-ion, lead acid. Already Shankar had already mentioned the lead acid battery, which is very common in our country, but other form of precious batteries like nickel cadmium, nickel metal hydride, lithium-ion batteries are not actually in our country. Those technologies we don't have. That is the problem we have. Okay, so the technologies are mainly in our country. Whatever the technology is indigenous is basically the lead acid battery, and we have several manufacturers of lead acid battery. But the problem for lead acid battery is basically the volume of the weight of the batteries is very large, so you cannot accommodate everywhere. Okay, so as Shankar already mentioned, that the charge density for the lead acid battery is quite less compared to the other tri-cell batteries. So nowadays, therefore, we are thinking basically for the lithium-ion batteries, which is having very high charge densities, and the charging time. That is another very important thing for electric vehicle. The charging time. The charging time also
Yes.
required for lithium-ion batteries are very less, because there are many researches are going on the fast charger. How within an hour we can charge the whole battery. Okay, for lead acid battery it may take 1 day, 24 hours. Okay, so these are the things that we must think when we are going for this application. Now for the transportation, the lithium ion battery is very much used, but the cost is a little bit high. Whatever the application we see in our day-to-day life, like e-rickshaw or this type of vehicle, those are still we are using basically the lead acid battery, because of those technologies we have. Now if we think of this lithium-ion battery, then the cost will be quite high, because the two things are there. One is the technology that I have already mentioned. The technology we don't have. Another thing is the material. Okay, so the material for
Yes.
lithium-ion batteries are all the mines we don't have. Okay, so that is the problem. Therefore, the cost there. Therefore, you have to import those batteries from the foreign countries, and the cost becomes very high. Okay, so these are the things we have to think when we are going for the storage batteries, and we are going for the e-transportation. Okay, so that is the thing we have to. Okay, so we have the have our eminent speaker for our today's webinar, and I think he will be enlightening you on this particular topic, challenges and how to mitigate those. So I wish all the success of this particular webinar. Thank you very much.
Thank you so much, sir, for the valuable speech. Now, I would like to call upon Professor Dr. Arun Kumar Bor, Dean of Engineering, Institute of Engineering and Management, Kolkata, and HOD of Mechanical and Electrical and Electronics Engineering Department, to say a few words.
Okay. Thank you, Shoma. So, good afternoon, everybody. And
Good afternoon,
so,
sir.
and
Good
most
afternoon.
welcome, Professor Mukhopadhyay and Professor Rai for giving the valuable time to this program. So already they are the expert already mentioned everything. I don't want to say anything more, but this is really everybody we know that the energy cannot destroy or cannot create. So only we can change one form to another form. So as an electrical engineer or a mechanical engineer, we know that in a mechanical device, the flywheel acts as the energy reservoir, but that also for some time. And similarly, in case of electrical engineering, the battery uh, is acts as a storage device, but this is also a very temporary mode. I can recall my memory from my childhood that at that time uh, my mic system they used normally the battery system. They carry two batteries, and not only that, they every day required to recharge the battery. Okay, and repeatedly, frequently in every week, at least they should have to put some distilled water
Yes, sir.
for the maintenance purpose. But nowadays, due to the advancement of the technology, the battery quality already improved, and not only that, the lithium-ion battery also improved the quality of the storage device. So now many more research work also required, and I will expect that the expert will explain more about this. So best wishes for the program. Thank you, everybody.
Thank you so much, sir, for sharing your perspectives about the webinar. Now, I would like to call Professor Tapas Kumar Datta, HOD of Electrical Engineering Department. Sir, we would like you to share your thoughts with us on the webinar.
Mr. Hello, am I audible?
Yes, sir.
Mr. Shankar Mukhopadhyay and
Sir, you are not audible.
problem.
Okay, now it is okay, sir.
Sir, you-
Some network issue is there.
sir,
Hello. কিরায় মানুষরা ও ওনার সঙ্গেই তো
Am
ঠিক
I
আছে
audible?
আমি ওইটা শুনছি।
yes, sir, you're audible.
সবচেয়ে ভালো লাগছে।
Yes, very.
হ্যাঁ
Yes, sir,
Because
you're
of
audible.
signal problem, I am using other phone. Okay, so
Yes, sir.
this today's topic is a very burning topic. That is your role of battery storage towards sustainable transportation. I am thankful to IET Young Professional section, Kolkata, for arranging this topic. Mr. Shankar Mukhopadhyay explained what is sustainable transportation. I would like to add only that United Nations has set 17 sustainable development goals, out of the 17 goals, actually all the sustainable development actually means development that meets the need of the present without compromising the need of the future generation. That is the main motto. And we are concentrating as an engineer on Sustainable Development Goal 7, that is regarding arranging affordable clean energy, and Sustainable Development Goal 13, that is combating climatic change and its impact.
Yes.
Mr. Mukhopadhyay also explained that problem of global warming and why we should have electric vehicle instead of conventional automobiles.
Yes, sir.
Yes, sir.
You will be very glad to know that global sales of automobiles, means conventional automobiles, crashed down in 2020 last year due to pandemic. But sale of electric vehicle increased by 41%. As on today, nearly 10 million light electric vehicle and 1 million heavy electric vehicle, that means electric bus and trucks, are running globally.
Yes, sir.
And battery, is the energy storage for all these vehicles. And we expect that coming 10 years, all the conventional automobiles will be replaced by electric vehicles. But some points, this is a good side, but as an engineer, we should remember that a typical electric car uses 6 times mineral inputs over the conventional automobiles. The supply chain, the other technological challenges for the battery storage has been explained. But some points I want to add, that the supply chain of clean energy technology and raw materials are very, very geographically concentrated. Actually, oil and gases are available all over the earth, but the material like lithium, cobalt, rare earth material, like these are very much concentrated in 3 countries. 3 countries are producing 75% mineral of these critical metals which are required for electric vehicle. Countries are Congo, China and Australia. But you will be surprised if you see the processing of the minerals to produce the critical metals. China produces 75% of it. So you can very well understand that lithium-ion technology of storage battery may be encountering a big challenge of scarcity of input material. So it is required for a different technology, different types of inputs for the storage battery if we want to sustain the pace of replacement of conventional automobiles by electric vehicles.
Yes, sir.
Another point relevant of today's scenario, and research should go on, that when such a large number of electrical vehicles will be there, then what we will do with the dead batteries? Every 2-3 years, battery has to be changed. Then after the lifetime of the electric vehicles, then what we will do with this storage battery? All the input materials are costly, resources are limited, so research should go on to recycle the battery.
Yes.
Present technology is very costly, so people are not that much interested. But when electric vehicle will come in full swing, replacing the conventional vehicle, then that will be a dire necessity. So let us enlighten today with the talk of Dr. Ankur Bhattacharjee on this role of battery storage towards sustainable transportation. I wish all success of his talk, and I am confident that our members will be learning a lot from today's lecture. Thank you very much.
Thank you so much, sir, for sharing your views with us on the webinar. Without wasting much time, let's call Mr. Shubhajit Bhomik, who is an IET YPS chairman of Kolkata Local Network, to say a few words about the webinar.
Is Sir here?
No, sir. Okay, sir is not present.
Hello. Hello.
Yes, sir. Yes, sir.
Yes, sir, you're audible. Oh,
I guess, sir.
Sir,
I think he has got some network issue, I guess.
Yes, he's getting
yes,
muted.
sir.
So, sir,
So
can we
let's
move
move on now.
Yes, please move on.
So now I would like to introduce our speaker of the day, Dr. Ankur Bhattacharjee, who did his BTech in Electrical Engineering from West Bengal University of Technology in 2010 and MTech from Bengal Engineering and Science University Shibpur, presently known as IIEST Shibpur, in the year 2012. He was awarded PhD degree in Renewable Energy from Indian Institute of Engineering Science and Technology in Shibpur in 2018. Presently, he is working as an assistant professor in the Department of Electrical and Electronics Engineering at BITS Pilani, Hyderabad campus, India. He has over 8 years of teaching and research experience in the area of electrical engineering. He has published over 34 research articles in reputed international journals, conferences, book chapters, and a book in the area of renewable energy and battery storage. He has also filed 3 patents so far in his area of expertise. His present areas of research interest are battery energy storage systems, electrical vehicles, microgrids, and power electronic converters. The stage is all yours, sir. You can proceed with the webinar now.
Yes, hello. Good evening, everyone.
Good evening, sir.
Yeah, for a nice introduction. Thank you very much. And I really feel honored to be present here and to say a few words on. I hope it will help you in this area of electric vehicles and role of battery storages in the field of electric vehicles, especially in the domain is sustainable transportation, but we will mainly focus on the electric vehicles here. And of course, before I start, I should say thanks to such a good introduction to the area of our topic today to Mr. Shankar Mukhopadhyay and Professor Sushant Dore, Professor Arun Bar, and Professor Datta for such a wonderful introduction of this domain. You can say we can have an idea. By this time, you have got that background of this area or what we are going to discuss about.
Yes.
Yeah. So I guess with this introduction of the background of the topic, we should not waste much time on this background study. Let us try to concentrate on more on this topic and the major interest area where we are basically focusing today in the role of battery storage in sustainable transportation. So let me share the screen. Just a moment. I guess I'm audible, right? Is it fine?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir, you're audible.
Yeah, thank you. So let me. Is it visible now?
Yes, sir.
Can you see this screen?
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
thank you very much. So, yeah, with all, I hope that your point of interest today of my discussion is the students of undergrad level, and so undergraduate students, especially I guess for the electrical electronics people are here. So thinking that in mind, we have designed some subtopics here, especially for this topic of role of battery storage towards sustainable transportation. It's challenges we face, and it's how to mitigate or possible ways to mitigate these challenges. So today's topic will be based on this following content. At first, we should know at every aspect of discussion, we should have a motivation, means why should we go for that? And then, of course, as many initially our professors already said that sustainable transportation, what is that? And of course, leading to sustainable development of the society. And then in this venture, role of battery storage. So it's challenges it faces, and then possible solutions that we have as of now, and we might have in future. So those are basically my point of interest to discuss about, and hope it will be interactive one. And of course, students will be having some good points out of it, and some research interest also. That is the most important part of this discussion. And of course, I guess the organizers have already kept some time to say interact after the session. So let me show you something about, or you can say some statistical data, which will say draw your interest more to this area, where see the transportation sector, as we see that it contributes 23% of the global greenhouse emissions. That is the most important part we should look after. And because mostly the engines are IC engines and they use the fossil fuels to run. So that is the most important part we should keep in mind. And thinking of among this entire, say, transportation sector, road transport takes a major share of 75% of the say, mostly these your contribution to the greenhouse gases. And of course, if it's the practice, of course, it will be more in coming future. So definitely it will be more with the time. So that is the other concern. And then to say face those challenges and to overcome those part. And of course, we should have some try. And of course, globally, there are the efforts have been done, and that is remaining in the green transportation. There is a new name, is very catchy name. The name as green transportation, which actually is you can say a domain of sustainable transportation, which our professors already discussed about that at the beginning. So I won't talk much about that. Again, I won't repeat those things, but still I would like to add something that in that under this green transportation, electric bikes, 3 and 4 wheeler vehicles, mostly electric vehicles, and green trains, mostly they are, you can say the road transports, they comes under that. So in many countries, there is a focus. And of course, we should not forget that to run those engines, electric engines, we need those electric drive system, and definitely that is powered by batteries. So batteries are the key component of powering those transportation systems. So we will mainly focus on the batteries, which are basically used in the green transportation. Of course, towards these face some challenges, as Professor T.K. Datta also raised some points at the towards the end of the introduction and the inauguration session, that batteries have some issues and challenges. We will try to look after those things also. I will give you some glimpse of that in this lecture as much as possible. So last point is definitely we should always concentrate and focus towards the integration of renewable energy sources. That is, of course, to promote the green energy and green, and of course, you can say sustainable development through sustainable transportation. And of course, as we say, the popular renewable sources, especially in all over the world, there is solar and wind, especially based on its availability, we can say, and as a power supply to the eco-friendly transportation. So last part will be definitely the interfacing of the battery storages with those renewable sources. So keeping that motivation in mind, so let us try to face those issues and try to mitigate one by one. So before we start from that major focus, let me tell you that you can see in the pictorial view of sustainable transportation in a society that it involves many transportation media. And of course, I already covered those areas as a background study of our professors already, that is regarding what is sustainable transportation. So with that, let us focus mostly on the electric vehicles here, because majorly it contributes in the, say, faster growth of sustainable transportation, because we need a faster life day by day. So electric vehicles are going to play a key role in that. And of course, it promotes the green mode of transportation. So you can see, in a nutshell, you can see there are renewable sources, there are storage, there are EV, electric vehicle charging stations, there are electric vehicles where the vehicle is getting charged, of course, to run the system. And then I would like to give you a small glimpse of what is going on around the world. In the world, there is now a special, you can say, a statistical data I would like to share. Because before you go to the technology, always being an engineering student, I feel that before you go for a technology, you should know the basic need of that technology, and of course, what is the status in the globally across the world, what is the status and where we are and where we have to go. So that is the thing. So for that, few slides I have invested for this background study, in addition to what our professor already said. So and then, see, 2020 till 2020, there are two. See, left side is for the vehicle stock, means a type of vehicles, of course, that we have, the region wise, and then the mode of transportation. You can see here that majorly contributed by China and Europe. You can see till 2020 region wise, and it's exponentially raising towards that 2010 to 20 in this last decade. And of course, the major contributors of this electric vehicles are, see the blue one, that is a PLDV is nothing but the passenger light duty vehicles that you already know that we have always availing those passenger vehicles, and out of that, these light duty vehicles means taxis and all four-wheeler cars, which carries us from one place to another place using the, say, electric vehicle. Globally, if we consider, that is a global data, and from that International Energy Storage Association of 2021 report, we can say that mostly it is contributed by the passenger light duty vehicles, and then comes that your sorry, LCVs, that is the light commercial vehicles after that. So these are the major contributors to the electric vehicles in terms of millions, you can say, throughout the world as of now in 2020. But we have a good projection, which is quite interesting. That is, by the growth we have projected, that is global growth by 2030, is that the state policies scenario, if we consider, it becomes, see the range here, around, let's say, the major contributor again, you can say passenger light duty vehicles, and of course, after that, the light commercial vehicles are the next contributors. And you please keep in mind, you just have a look, in this PLDV, here is another term called BEV, that is a battery electric vehicles. Means there are basically, if you can see as of now, if you have some lookout of this, a few of you, I guess, you have the background of type of the electric vehicles, or you can say sometimes there are hybrid vehicles, which a combination of IC engines and batteries both. There is a switch mode in between those. So that is called plug-in hybrid electric vehicles, PHEV, and there are totally battery operated vehicles. So today's discussion, we will mostly talk about these BEVs, because our, that we, in our projection of that reduced carbon footprint and the environmental aspects to reduce the greenhouse gas emissions, we would like to reduce the use of fossil fuels and IC engine applications as less as possible and promote towards the battery operated vehicles. Of course, these are challenges. Those we will basically discuss about in details in the coming slides. But of course, before that, the need of BEVs, battery operated vehicles, and the growth you should know, then only you can get the interest to know the technology, right? So
sorry to interrupt you, sir.
Yes,
the attendance link has been given in the chat box.
Okay.
I would request all the participants to fill it up so as to get their respective certificates. Thank you so much, sir. You can continue.
Okay, thank you, Shreya. Okay, so Yes, you can see the right side curve. It gives the data of by 2030 we are having this growth, as you can see, compared to this around 70 million to, you can see the growth is about 130, 140 million. So it's almost twice by 2030 in our 10 years, coming 10 years as per the global outlook. And of course, with this motivation, in India now, our point of view is in India, we are far behind the global scenario as of now, but the growth you can see is really commendable. That is EV stock, means that in terms of cars, we have said that 2010 to 20, there was a small growth now as of now. In the BEV, we are talking about only battery electric vehicles here, and not the PHEV, means not the plug-in hybrid electric vehicles. So we will talk about mostly on the battery, because the topic of today's discussion is battery storage role in the sustainable transportation. So we'll mostly talk about the BEVs here. And see, at around say 2020, we had around 13,000 EV stock in India as of now, in four-wheeler, three-wheeler, and two-wheeler, if we talk about these things. And then you can see the basic component. Before you go to the next slide, means the battery operation and battery roles. You should know the basic components of electric vehicles, because otherwise, what is actually role of battery storage, that we won't be able to appreciate, right? So for that, this electric vehicle is a generic electric vehicle, your schematic, which is having majorly 3 or 4 components. Right from the internal structure is that to drive this your say engine, that is electric engine, that is driven by the suitable power electronic converters, DC to DC, DC to AC, because we know in our popular electric vehicle, your engines are mostly driven by, our wheels are driven by the motors, and mostly AC motors are there, and there are the PMSM, there are induction motors, and there are, of course, nowadays there are switch reluctance motors are also being used in an extensive manner in electric vehicles by many companies. And so these all are basically, you have to maintain the proper voltage, and of course you have to maintain, because the motor has to carry a torque, which is of course dynamic and random in nature, and we have to give those sufficient safety as well as a power supply, reliable power supply, with the help of these power electronic converters, and of course which will be fed by the battery storage as a heart of the system, which is the power supply. Because when you talk about the battery electric vehicles, the battery storage is the major power supply in a standalone mode when the vehicle is running. So in that case, we need the battery storage as a major part here. And to charge this battery, there are the charging stations outside the vehicle. Of course, we will talk about that also in the sustainable transportation, not only vehicle, but also how to power those vehicle, how this vehicle will be running based on the batteries. So this schematic will give you a brief idea of what is actually inside the electric vehicles majorly, because there are the control circuit I have not shown here, because that is a different aspect of research and aspect of application of control circuit design. There is a complex control inside the electric vehicle. I am just showing you a very generic component diagram of electric vehicle here to have an idea of what is actually the major components in electric vehicles. Okay, so now, as I said, the battery is for sustainable transportation. That is, you can see that I would like to share with you 1 or 2 more information that is useful for our discussion. That is, till 2018, we had globally 180 gigawatt hour of battery storage as of now as stock. Of course, not to only promote the sustainable transportation, but to also in the power sectors. Of course, with the help of renewable energy integration, we are having this kind of huge growth in the battery storage. And by 2030, the projection is towards 2,600 gigawatt hour. Please mind that number. It is a gigawatt hour scale we are talking about in a storage factories. Okay, so to power the entire system powered by renewable energy, because as we know that whenever we talk about the renewable energy, or you can say sustainable energy, to be very precise, then renewable energies, of course, although it reduces carbon footprint, clean energy, but of course they are having the intermittency in nature, because they depend on the weather conditions, and of course the variability of the weather affects their generation. So you have to have some reliable power supply where you can store the energy for a while, and then you can, in the other form, from in the other form, electrical to chemical. So electrochemical energy storage, basically in terms of batteries, we can say. And BEVs, as important part you need to note is that it is accounting 2/3 of the new electric cars registration globally in 2020, despite COVID-19 pandemic. As Professor T.K. Datta also raised the point, is that the IC engine-based vehicles, automobile industry, those are, or you can say conventional automobile industries, those crashed, but still the electric vehicle industry has risen up to say some extent, of course, significantly in the countries of Europe and China. And you see, as a data, we need to know for the global aspects is that Netherlands, Norway, UK, these are the countries, France, these are having significant growth in the battery electric vehicles and as a share, global share of the electric vehicles. And you should not forget our own country growth, that is India has increased electric bus registrations by 34% up to 600 by 2020 in this situation even. And policy targets electrifying the 25% of vehicle by 2024, means all the vehicle up to 1/4 of the vehicle should be an electric vehicle as per the aspects, the policy of 2024, which is almost very fast you have to grow, and 50% of all the new buses will be battery powered. That is the target. Let's see what happens with this vision. And for that, as you know, to promote this one, your India in scenario, there is a popular, there is policy called FAME, that is faster adoption and manufacturing of electric vehicles. Under that, India has planned to go for a EV 30 at 30, because that is nothing but the 30% of the new sales share of EVs by 2030, which actually is translating or leading towards, you see the numbers, 24 million of two-wheeler vehicles, 2.9 million of three-wheeler, and 5.4 millions of four-wheeler EVs in next 10 years. So you can see the need of battery storage that we have in the upcoming 10 years to run these electric vehicle projects. So by 2035, India will need to set up its own, as you see, to meet this demand, we have to have the supply. And of course, as professors also said about at the beginning, that cost and availability of raw materials, and of course this customs duty and those foreign purchasing policies, of course, they are huge cost is involved. For that, we need to set up our own gigafactories of battery storage in the next 15 years. And you see, if we can meet this in next decade, India's annual requirement of lithium-ion battery storage, because we will mostly focus on this battery. Why? Because I will tell you some slides later, is projected to reach 17% to 70% of annual global production of battery storage. So you can see how much significant contributor India will be having as in the demand point of view. So because you know that huge population is there, and of course, if we can improve the sustainable development scheme through this electric vehicle, of course, it will come in the picture in coming 15 years. Definitely, that will be a significant demand in India of battery storages. And of course, these are the data that we can say from Indian Energy Storage Association of India by this outlook. And as we said, just to have a look that you can see the growth here. You see the EV, two-wheeler, three-wheeler, and four-wheelers, and electric buses. They are mainly categorically, there are four patterns we can say categorize the electric vehicles. And you can see the growth here, 2022 and 2032, you can see the growth, 4 to 441, three-wheelers 26 to 67, because three-wheelers are basically auto rickshaws and all for the rural people. So definitely it has a significant, in terms of this battery storage requirement will be, because low capacity battery is sufficient to run this three-wheeler, those e-rickshaws and all, e-mobility to run this system. So battery storage requirement in terms of course, gigawatt hour again, because that is again, the number is huge, but of course, corresponding, with respect to this electric bikes and the four-wheeler vehicles, we are having this tendency of this passenger vehicles are, of course, more compared to the all others, so it is dominant. You can see 615 gigawatt hour means energy in terms of, because over the time we will have to consider. So over the coming 10 years, we have from 8 to 615 gigawatt hour of battery storage requirement to run this target of four-wheeler electric vehicles. And so you can see as a whole, by coming 10 years, we are having almost 1400 gigawatt hour of battery storage plant, our capacity or stock to run this or to ensure smooth running of the systems. And it is a big challenge, because there are the constraints are there, but definitely you have to look after those constraints and try to mitigate as much as possible in this talk. Okay, so let's have a look this one. Sorry. If you can see, it's a very interesting thing that as Professor initially Mr. Mukhopadhyay told about the battery storage, popular battery storages for electric vehicles. That is a lead-acid battery, nickel metal halide batteries, and the lithium-ion batteries. Basically, there are three popular batteries as of now in electric vehicle industries. Of course, after that, lead-acid batteries are lagging behind because of their the limitations of charging cycles in terms of the lifespan is less compared to the other two batteries. And of course, the charging rate, you can see some parameters I have taken. It may take some time for you to understand because you are in undergraduate level, but of course, if you have the interest, you can see the literatures published so far, and of course the research papers, which gives you the idea of industrial research, what is going on the battery storages, and to promote the electric vehicle industry. See the charging rate, because we know that EV has to be charged with a certain rate. C rate is nothing but the capacity of ampere hour. You know, in the inverters also, so far you have well known of the batteries, mobile batteries. These are 4,000 milliampere hour in mobile batteries, 5,000 milliampere hour for the smartphones. And then in our inverter vehicles, inverter batteries, we are having say 100 ampere hour, 150 ampere hour, say 60 ampere hour, and so on. So that C rate is nothing but the capacity or ampere hour. So lead-acid battery, it has some limitations of slow charging is possible because it is internal electrochemistry is a concern. That is a C6 rate, basically you can say, or C3, rather it should be C3, sorry. So C3 is a standard rate of charging lead-acid batteries, but for the electric vehicle point of view, the lead-acid batteries are having limitations, although the cost is low. But for stationary storages, our household applications, still lead-acid batteries are coming slowly, coming fast. But for the electric vehicles point of view, lead-acid batteries are not that suitable because of their limitations in the cycle life, as well as the charging rate is of course low. And in EV charging, we need fast charging because we have to use it, say charge it by 30 minutes, 40 minutes, and then run for a few hours. That is our target throughout the day. So for that case, NIMH batteries, nickel metal halide batteries are also popular in this case. Some of the vehicles are there which involves NIMH batteries, but still the charge is not that much you're sufficient enough to have a fast charging. And of course the part cell voltage means charge density also in terms of the cell voltage is also less, 1.2 volts per cell. So that is another limitation of this NIMH batteries. But keeping these things in mind, our most interest, we have all over the world for EVs, most popular batteries are now lithium-ion batteries based on its higher or moderately higher charging cycle and discharging cycles, because lifespan is more compared to this other two, you can see by the data. And as you say, the charge density, as professor said, that the energy density should be very high because we should make it portable, right? Smaller in size. So energy density should be very high. So that reason lithium-ion battery is chosen. And as you can see, the range of the charge, it is very high. So fast charging is possible for these batteries, of course, with some protection. So we should not leave those protection part apart. Definitely, we will talk about this also as a challenge, because we can use this fast charging for these batteries, but of course with some protections. And so nowadays, lithium-ion batteries cost is still high, as you can see, and it's a global cost scenario. And but still, the research is going on to reduce the cost of lithium-ion batteries, of course, in association with that lithium-ion electronic circuits to run this system, which is called a BESS, that is called a Battery Energy Storage System, which is a very popular name in the field of electric vehicles. And see, let me tell you what is DOT. Those who don't have the exposure in the battery storages, for them it's unknown term. That is, one is called SOC, state of charge, means how much charge is left there, how much it is charged now. And what is DOT, that is the depth of discharge. These are complementary in nature. SOC, state of charge, 90% means depth of discharge is 10%, it is remaining. So means how much of depth of discharge means up to how long we can discharge the battery, we should know. So continuously monitoring should be required to run these battery operated vehicles. So there are challenges, we will show one by one what are those. And so with this, as we can see that the lithium-ion batteries are very much accepted in the point of view of cycle life and its charge density. Of course, its efficiency of DC-DC means why? Because battery is a DC, no? So DC power supply you have to give to charge the battery. Similarly, DC output will get. So that is how much we are giving and how much we are getting out of it. So it's a DC-DC efficiency of cycle that is also higher for this battery, and moreover it is portable in nature. So for electric vehicle applications, lithium-ion batteries are mostly accepted as of now all over the world. And it is the charging rate, of course, very fast. So fast charging rate is required for the batteries because we don't have all the day to charge the batteries, and we have to have hundreds of vehicles in a parallel charging stations throughout the day. So there should not take 30 minutes, 40 minutes and beyond to take those charging station operated batteries. Let me tell you something about these challenges, because as we know that focus is our batteries are required that we know, so we know the advantage of those things, but there are challenges. There are challenges we should mitigate those challenges, but we should be aware of those challenges first. That is a stringent charging and discharging characteristics of batteries. Of course, the lithium-ion battery, I will show after the next slide that how the charging your profile, say it affects the battery life, and of course undergoes thermal runaway and explosion due to rapid temperature rise inside the battery stack during irregular charging discharging. That is one more important part. Second point is very interesting. That's why the stringent charging discharging characteristics is required. So we have to use or have to design the charge controller in such a way. Charge controller means that power electronic circuits, if you can recall from the electric vehicle component, that we have shown the subsystems where the power electronic converters and the charge controllers should be such designed that this thermal runaway can be avoided, because these are compact in design, as we can see that high charge density, high energy density rather you can say. So for this high energy density, if you go for fast charging, so definitely that heat inside the battery will be very much, and it will go towards the thermal runaway inside the battery, and for prolonged thermal runaway inside the battery, it will lead to explosion. So there is one recent news in South Korea, in Seoul, in 1920, we had a 150 megawatt hour of lithium-ion battery factory got explosion occurred, and the whole almost area wiped out because of this irregular charging, and monitoring was not also proper. So that is a crucial part of this battery storage of lithium-ion when it is concerned. But we have to also mitigate those things by some means. We will show you one by one. And third point is very interesting, that as a result, it needs a proper protection compared to other batteries. So cost is also very high when it is compared to the BESS, as I said. It's not a battery only. It's a battery pack along with the electronic circuits and thermal management systems. The entire system is called a BESS. So whenever you go for the solution providers of electric vehicles, they do not provide the battery pack only, because they cannot leave it up to the consumers. They provide the BESS system, means a solution which requires thermal, electrical protections, and also the chemical aging inside the battery. Continuous chemical reactions, it is happening while charging, discharging. So definitely it should affect the battery storage lifetime as well. We should take care of that thing. So BESS includes everything. So now this auxiliary circuit and support, as I said, is required for the lithium-ion battery storage, which increase the cost. And of course, the major or the heart of this BESS is BMS. It is called a popular name in the technological aspect nowadays in the research field of electric vehicle, that is a battery management systems. So for electric vehicle point of view, where random discharging is required, because whenever say it is going to ramp up in a road, and depending on the uneven road surface or profile of the roads, the motor needs the torque to supply the torque, right, to climb those hilly areas somewhere. So definitely the electric vehicle, if you are talking about, definitely the battery draining out with time will be more. So to look after those issues, we have to use proper battery management systems to ensure smooth operation. Now, the thermal operating range of lithium-ion batteries, as I said, just have a look in this previous one, the thermal runaway is possible. So for that, this point is very important, that 15 degrees Celsius you can see, it is a standard by manufacturers end, and 35 degrees Celsius is the stringent window which we have to maintain of the temperature for the lithium-ion battery storage while charging and discharging. So that is most important part. And below 15 degrees Celsius, if we go for, then sluggish electrochemistry means inside the reaction will be slower because of the battery properties. I won't go to the detail of the chemistry here. and that is of the electrochemist can say better than that. The sluggish electrochemistry, because of that, we are electrical engineers, we would look after those points from the outside world, because we have to have the sensors, and definitely battery health should be monitoring. There are some means how to monitor the health of the battery in terms of state of charge, in terms of temperature rise inside the stack, a battery stack, inside say in terms of the depth of discharge, in terms of those remaining useful life, in terms of the battery charging discharging characteristics. Those are the parameters we will look after as an electrical electronics engineers. So and this battery design means fabrication of electrode, electrolyte, those areas are the contribution for the electrochemist, so that the cycle life sorry, and the aging, chemical aging can be can be overcome. So now this beyond 35 degrees Celsius is the most concern, that is degradation of battery capacity. Although the charging will be slower, discharging will be slower in this case if it is below the 15 degrees Celsius. So performance will be degraded, but here life will be degraded. That is most important part, beyond a certain limit. So we should use some thermal management system in the battery storage along with these charge controllers, so that during charging discharging the battery's temperature should not go beyond this one when we are talking about lithium-ion batteries. So this degradation of this battery capacity, or it can go to capacity fading, it is called fade of capacity with say when the new battery to older battery, at the battery gets older. So this capacity degradation takes place because of many reasons. That is a chemical aging, thermal aging. Of course, it is the battery internal impedance. Sometimes it increases with time. Of course, with the chemical aging, of course, that is another important thing, because impedance is not our electrical impedance, that is a chemical parameter. We are assuming that in terms of lossy components, so we assume as a electrical, as a resistance of internal resistance of the battery. We assume it as a RC model of the battery, where R and C are not those electrical R and C, those are electrochemicals parameters, and the chemical reactions are basically concerned, which varies, which affects the value of this R and C with time. So these R and C are not constant. Battery resistance, battery capacity are not constant, they vary with time, and mostly they degrade with time because there are some issues. So that to restrict the degradation, or you can say to slower the degradation rate, we should use some technology. So that I will go one by one here. See, before we go to the BMS part, in the electrical vehicle point of view, I would like to show you some simulation study for your interest. You must not have heard that the console is one such software. You see, console is you can have it open source also for you, the undergraduate students. You can choose the battery technology, battery study, and also electric vehicle study in terms of battery storage in your final year projects also under the professors you have there. And the console is such a software which is open source software. Of course, there are licensed versions, but you can use it as a student version also, where the features will be there available for you to study the battery characteristics under different charging discharging conditions. So console multiphysics is such a versatile software which is having the library where the different batteries are there: nickel cadmium, lithium-ion batteries, lead acid batteries. We are mainly focused here on the lithium-ion batteries. So in the lithium-ion batteries, you see there are temperature thermal modeling we did initially. I would like to show it here. That is a blue is a cool one. So definitely the cooler portion to the, we can say the higher temperature portion, and the red one is the hot spot. That is the inside the battery stack, or you can say ideally the central position. Practically there are different local hotspot also based on the irregular charging, discharging, or irregular chemical reaction takes place. So from the outside to inside, if you go, it is a 3D modeling of under the console software environment. That is thermal behavior of lithium-ion battery. A 40 ampere charging we examined for a 1 kilowatt hour battery. That with temperature you can see the hotspot temperature is 52 degrees Celsius, so over 50 degrees Celsius. So we can allow up to say this, say sky blue one, and towards maximum 35 degrees Celsius, as we have seen that this the window, or 35 degrees Celsius is a window to avoid this chemical aging of the batteries and to avoid the degradation of lifetime. So we should maintain, say this is a thermal behavior, means for high current charging, as we are talking about the fast charging, you see, fast charging we need, these all are cumulative effects. We need fast charging to charge the electric vehicles faster to save time, and to do that we need to have a high current charging. Faster means the charge is constant, so For higher current means lesser is the time. So that means for a particular battery, if you want to have fast charging, then definitely high current is possible. High current has to be supplied for the battery. So definitely that your high current charging will be I square RT, continuous heat generation inside the battery, which will lead to the thermal aging of, and of course for a compact design like lithium-ion battery storages, it will lead to explosion at some times if we do not monitor or properly continuous monitoring of the battery storage life is, and of course the temperature is not monitored properly, then it will happen. So we need a proper thermal management system for this battery, which of course involves extra cost, and that is your limited and it's a challenge in the battery lithium-ion battery storage, because we can't help at this stage using lithium-ion battery storages, because we have to use it for the several advantages over the other batteries for electric vehicles. But at the same time, we need to keep in mind the cost also. We are reducing the cost in terms of charge controllers and the vast advancement of power electronics nowadays in the coming last 10 years. And of course, the thermal management system is also taking care of this thing, that how to precisely monitor and control the temperature inside the battery by some technology. That is, I will help you in this understanding these cases in the coming slides. So now lithium-ion battery charging profile, as I said, a recommended charging profile. See the red one, dotted line is the current profile and the green is the voltage profile. See here, initially we will allow a soft charging. Is it audible and as well as visible? Can you please ensure me, somebody? Because I can't see you.
Yes, sir, you're audible and your screen is also visible.
Thank you very much. So let's continue. In this, the soft charging we allow, because we need to have the battery, you know that, say for example, when the battery is fully discharged at the initial stage, because we want to charge the battery, or say 10% of the state of charge is available, in that case, we would like to charge it. So if you want fast charging at the very beginning, say first a few percentage of charging, if we allow that, the battery storage, then definitely a very high current will be coming there, because higher to lower voltage always it flows. So battery voltage is very less. And compared to the power supply, if we apply a suitable converter in between, because I don't know how many of you have gone favor of the power electronics so far, but still you will study the second year students also if you are there. So the power electronics, of course, the DC-DC converters and charge controllers you will have to maintain the battery voltage for proper charging, and proper current also you have to maintain. So we have to maintain, first see, the first phase is up to say this much is a current control mode, means it is a current control mode, CC mode, and after there is a voltage control mode. So there is a CCCV charging, it is called popularly. So it is a general charging profile given by the manufacturers when you will buy lithium-ion battery pack. And so it is a recommended charging you have to maintain by suitable charge controllers. And see, initial soft charging we provide to avoid the initial highly say temperature rise inside the battery stack. Once the battery voltage reaches to some portion, then we allow high current charging, which is almost depending on the capacity, as I said in the comparisons table, that is a 2C, 1C and 4C up to that. Maximum C means the capacity, ampere hour capacity. We can have, let's say 40 ampere hour battery, where charging is 40 ampere. In C rate we are charging. If it is 80 ampere charging, so it is 2C rate. So in lithium-ion batteries, there is a possibility to make it fast charging, of course with the help of these protections. And up to a certain limit, we can say current can be maintained within a band, and then we can go for a voltage, constant voltage mode here. Constant voltage mode means once the voltage reaches, let's say it is a part cell, as I said, single cell voltage, we have just have a look, a single cell voltage. For series of cells, you make a stack, let's say for a 30 volts, 32 volts or 24 volt battery, we are having, say, cell voltage, let's say for 3 volts or 3.2, definitely 8 cells in series, we can say. And definitely the charging current part cell will be same because it is in series, but in voltage will be definitely added to make a voltage stack, right? So that is the capacity calculation we all have. So that to maintain this voltage, you see, we need a proper voltage controller, of course. That is true again power electronic devices. And this, if you maintain the voltage, automatically the current will slow down up to some point, which is again the safe limit. So we can claim the battery is fully charged if this profile is maintained. Otherwise, there will be incomplete charging, there will be incomplete or irregular charging, there will be sudden temperature rise if we try to say maintain fast charging at the very beginning. So this kind of soft charging is very essential for the few minutes, then we can start for the higher charging. It is called the bulk charging period. Soft charging, the bulk charging period is required. So bulk charging, we will reduce the time span. As we are saying, the target is to fast charge, and so up to a certain limit, we will apply a low current. Then we will have a higher current charging to maintain the so that the battery can withstand the temperature rise. Of course, we would like to always we have to maintain the temperature continuously inside the battery stack. And to as I said, to maintain those temperatures within the limit, there are some cooling technologies in the lithium-ion batteries. That is the air cooling, that is liquid cooling, and immersion-based cooling also. So those are the research work is being done. Those who are interested in battery storages later on, you can search for the research papers and of course the reported articles where the lithium-ion battery management system means thermal management is the most crucial part of lithium batteries. So how many cooling technologies so far has been used for the electric vehicles? The dry cooling means air cooling is possible through the channel series stack. Basically, there are the your coolant passage. So inlet of airflow, cool airflow through blowers, through fans. We know there is a very generic process. It of course it is not that effective whenever the temperature is beyond the limit. And for that, the liquid cooling is effective in that case. But still, again, you know that liquid cooling, we have some issues. So beyond 45, 50 degrees Celsius, we have some issues regarding liquid cooling technology. For that, we need a immersion-based cooling technology where the battery stack itself, we can see inside a coolant chamber. Of course, there is a polymer coated, you can say, so that the water content or liquid content should not come into the battery. It should be isolated properly. That protection we should take. It's a non-metallic sheet in between so that the coolant cannot be there. But around that coolant is there. Of course, through a small or micro pump and control valve, we would like from the coolant chamber. Of course, we would like to always say pump out this liquid here, and we extract the heat from the battery stack, and then we come through this control valve. And where there is a cooling through a radiator fan, continuously cooling, and then again recycle. So that cyclic process, it goes on as long as sensors we have, as long as we are not sensing it within the limit. So we will keep on, say, opening and closing the valves depending on the battery internal temperature. So within the safe limit, when it comes, we'll stop that process. So these are the cooling technologies. One is the air cooling, one is the liquid cooling, and there's a immersion-based liquid cooling for lithium batteries. Now I would like to have a comparison of these technology. As I said, what is the comparison? Means whichever you should take, you should adopt for the cooling technology for the electric vehicles. It is very popular now, but of course, some research is still going on, and we have done some research on this battery, experimental research also. That is, so red one is uncontrolled, as we said, with temperature, 40 ampere charging, as I said, over a 1 kilowatt lithium-ion battery. We have experimentation study we had done, and uncontrolled temperature, you can see it reaches to 50 degrees Celsius after some time. And if you go for air cooling, it will be managed within, say, 35, of course, up to some extent. And then liquid cooling is much better. Finally, the liquid immersion means when the battery stack itself is inside the chamber of liquid, then it will give the best result of us, where the battery operates in a regulated way, and of course the performance can be improved, because that continuous heating inside the battery gives the battery lifetime fading. Of course, the inside the battery thermal aging continuously, if we allow over the month and years, then definitely that should have been, let's say, for 5 to 6 years the battery should operate. We have to replace it by 2 years and 1.5 years. In same thing you can see in your mobiles also, that while purchasing you can see expected it will go for at least 3-4 years, but within 2 years the battery charging and those things, performance gets degraded, right? Because of irregular charging, discharging. Even we know these things, but we still allow irregular charging, discharging. Frequently we charge and discharge. So all the batteries are having their fixed charging, discharging cycles, but still we allow multiple times charging a day. Even let's say, for example, 40% charging, still we go for the charging. We are not allow them to be discharged till 10%. Then again, we allow for the charging. That sequence we do not maintain. That's why number of cycles we exhaust much before it should be. Okay, so I guess this is clear that this liquid immersion technique, how it helps in the electric vehicle technologies, where the randomness of the battery power discharge is concerned. And to cater this problem, in addition to the thermal management system, That is the overall aspect of BESS. As a typical, it is a BESS schematic. You will have a brief idea on what is actually a BESS operated inside electric vehicles. That is you see the battery packs are all, say it's a series of packs are there. It's a 3D diagram, and inside the BMS, inside the BMS there are several parameters. As at the beginning I have said, that precise state of charge means maintaining proper charge controller. Then accurate state of health means how much remaining useful life it is having, and then how much time it takes to discharge fully. That also you have to maintain. And then the cell balancing. So there are some battery storage. Sometimes you can see, let's say the 12-volt battery is having 6 cells or 3 cells in series. Sometimes it happens that due to irregularity of cell imbalance, one cell voltage is differing from another cell voltage. There will be a circulating current in between the 2 cells. So to avoid those things, that is a loss again. So to avoid that thing, we have to have a cell balancing technology. So there are the battery manufacturers and the battery factories, they are taking care of nowadays. Research is also going on the battery BESS, means the battery pack, how efficient it should be designed, okay, to overcome those issues of cell imbalancing, electrode aging, electrode material decays with time over the repetitive charging and discharging reactions inside the batteries. And of course, the interfacing part is most important, being electrical engineers, apart from the battery pack, that is a converter electronics, means power electronics to interface with renewable sources and the grid power supplies. Whenever we're talking about the battery charging stations, so definitely from the grid either or from the renewable sources, we have to charge the battery and discharge the battery, of course, say in electric vehicles, battery to discharge through the loads. Sometimes in electric vehicles, it is nothing but the motors. So definitely you have to discharge the batteries to run the electric engines. So this is the converter electronics, where of course you see the bidirectional flow is required, because charging discharging we should require for the bidirectional charge controllers. So these are the new terms, I guess, those who have not studied the power electronics yet, and the drives also. So, but it is very interesting, you should know. Here I am not giving you any mathematical things for the lecture classes, regular lecture classes, but I am here to give you a glimpse of an idea or where you have to focus on in the coming days to navigate yourself, that what sort of study beyond the curriculum. Also, in addition to that, you have to go for a project works, you have to go for some abroad if you want to have study in higher studies. For that, what work should be there and what background you should have from now. So those are the things. And of course, the industrial interfacing is required. So all these operations, a battery pack, its own management system, and this electrical interfacing through electronics, all should be monitored by the SCADA system, that is a supervisory control system. And of course, nowadays, all are having this AI-based, artificial intelligence-based, the monitoring systems are there to make it much faster and efficient nowadays. In all the electric vehicles, AI system is very much included nowadays in the global scenario. Okay, so these are the aspects of BESS to have this, to maintain these things. Now, as I said, the BMS is a key part of this BESS. Inside the BMS, as I said, there are few important points you have to look after. That is state of charge estimation, internal parameter estimation, that is internal impedance varies with time with charging discharging. That is another study. See, these 4 are the pillars of research nowadays on battery storages. Let me tell you, is that with the energy engineers, we do research on this battery storage in different aspects. One is electrical aspects, one is electrochemical aspects, one is the thermal aspects, and of course the stack design, battery design aspects, and rest of the part which is not to be neglected, that is the interfacing part. Means whenever we interface the battery or integrate the battery storage with other sources, how to integrate, what should be the efficient operation, what should be the efficient connection with those things. So that should be very interesting research areas in the coming days for you guys. Now, coming to the point of electric vehicle, directly if you can see as an outlook that how the BESS is getting operated in the electric vehicle aspects. This part I won't again repeat, because the electronic controller unit is required to control the whole operations. And right from the accelerator, when you will push that, the battery needs to discharge the power more. And then electronic control system is required. And power converters, means DC to DC, sometimes DC to AC, sometimes AC to DC also, depending on where the power flows from the battery or to the battery. So from that to the motor and to the, of course, the drive portion to drive the wheels of the electric vehicles. And this BMS plays a great role here, not only to monitor the battery health, battery condition, but also this BMS will finally take care of how the battery is getting discharged, because batteries has to supply in electric vehicles, the internal circuitry, internal air conditioning system, internal communication system to operate the battery the vehicle smoothly. So battery is not only driving the power to the motor, but also to the entire amenities, electronic gadgets inside. So battery is the heart of the system. We need to monitor continuously with the help of BMS. So that is the outlook of the electric vehicle aspect in the battery management system. Now, let's concentrate in a deeper way. For a single slide, I'm investing here. For a single slide, just to have a look at what is the idea of how to establish this communication between this battery management system and the battery for the whole system. See, there is a master control layer, there is a slave control layer. Those who are having the ideas of SCADA systems, a little bit idea, not much required. So there is a master control, there is a slave control, means there are 2 layer controls are there. So battery pack, the battery pack plus and minus are there. The sensors are basically, they senses the battery voltage, the temperature, you see the current, all those things are sensed. Then from the modules, you see the series of modules are there, this one, in a, let's say, large battery pack, okay. So series of modules are there. Let's say electric bus we are talking about. So a big battery pack is there. So in that case, how to control this? So all the sensed values, they are say communicated to. There are basically, it is called a CAN bus system. There is a control area network. There is a specific area of CAN bus control system. That is not in your undergraduate studies. Definitely, it will be higher one. But I would like to give you some ideas on this battery management system, how it works. So it is a CAN bus system, is control area network. So where is that? There is a you see there's the bus. The control signals can be operated using a control when from the electric parts to the controller and then getting back. So it is a feedback system all around. So the communication is established by a CAN bus system. Of course, sometimes wireless, sometimes wired. So there are 2 communication modes of communication. Sometimes the GPRS and GSM based also. The batteries are nowadays advanced technology electric vehicals. Tesla and Mitsubishi, these are Mercedes, these are the companies who are in Germany. They are inventing, and of course, they are in fact they are implementing those electric vehicles which are AI based totally. And of course, the communication system is the battery management. Of course, it's the heart of the system. The communication system they are maintaining with the help of wireless communications. So these are the aspects of different aspects of battery. But I won't talk about much in this battery communication part. But of course, the battery, your ideas of what you actually need being electrical engineers. You see, when I guess at the beginning, Professor T.K. Datta raised one important point, that what about this battery life? And after this life of the battery, I guess I have not much time, so I will take 10 minutes more. Is it possible? Am I allowed?
Yes, sir.
Yeah, am I allowed to go for 10 more minutes?
Yes, sir. Yes.
Okay, thank you. Yeah, so the 10 to 15 more minutes I'll take, because I would like to give you some outlook at the end. See, with the flow we are passing through this, right from the battery we started, and the electric vehicle aspects, global scenario, and then how the battery is located, how it is being operated, what are the protection we should take care of from the battery in the thermal point of view, in the charging point of view, and then come to the fate of the batteries. Fate of the electric vehicle batteries at the end of first life. This is a very important part for your knowledge. There is a first life of a battery. What is a first life? As I said, a new battery. After the manufacturing a new battery, we're using it directly. First point is in the electric vehicles, they should be used. The refined and the new battery, it should be used for the electric vehicles. Then from the electric vehicles, once say over the years, the vehicle is operated, then what is the fate of it? That should be also kept in mind, because we should not only use it, we should know where we have to dispose or we have to recycle or we have to reuse this battery, as a matter of fact. Now, this battery recovered, as I said, battery recovered at the end of first life and tested. So after some time with the battery, we can see manufacturer specified life is almost towards an end. Then we will see some parameters. We'll test it in the laboratory that how is the life of the battery, or remaining useful life of the battery after some years. So if there are some components to test it, and then the remaining useful life of the battery should be judged in such a way that we should be able to decide whether it is exhausted or whether it is viable, still life is there. Means in terms of energy density, energy capacity, ampere hour, means how much time it is taking to charge, how much time it is taking to discharge. As you know from the mobiles also, let's not talk about the EVs now, and let's say for the mobiles, you know that for the new batteries you take say half an hour or 40 minutes to charge, and then almost 4 or 5 hours even if you do the Facebook and all online studies in here. In case of the online mode of education, your mobile is extensively being used in laptops also. So you can use the smartphones extensively now because the batteries are the device source of power. And you see in this case over the time you can see the battery is taking more time to charge and then relatively less time to discharge. That means the capacity is getting faded, right, with time. So here also for the electric vehicles it happens. And for that, the exhausted battery, if it is exhausted means no use, we can say, then we have to go for recycling in the battery. We should not dispose it because battery inside lithium and other chemical things are toxic to environment. So we will go as long as possible with the use of the battery. Let's say try to have recycling. There are recycling plants and the companies are coming up in Europe and China in a large manner in last 5-6 years. The interest has become for the recycling of the batteries, keeping in mind the huge disposal point of view into the environment, because we are all moving towards the renewable sources and where the battery storage is the key. We cannot avoid that. Whether it is a power sector, whether it is electric vehicle sectors, whether it is communication sectors, telecom sectors, everywhere we need batteries nowadays to have reliable power supply. So we have to know the fate of the batteries. Now this recycling plants, after recycling, there is a newly it can be used, but of course with a reduced capacity. But you see another part, remaining viable life after the first life, remaining viable life, we straight away use to the battery repurposing workshops. Means by some means you have to repurpose this battery by some further improvement. Chemically we cannot improve, but of course the circuitry approach we can improve it. We can process the battery storage again. We won't dispose and we won't disassemble the battery, but we have some treatment. Treatment is there in the workshops of repurposing. There are two terms: recycling, repurposing. So repurpose of the battery, we use it as somebody was telling in the beginning that the battery we should also keep in mind not only in EVs but also in power sectors. That is the energy sectors. I mean renewable energy integration, those things. And repurposed batteries placed on market as a new product. For the second life applications, they are placed as a new product by again through a company. Of course, they process it by they improve something, and then they come to the second life. And this is basically used for the renewable energy integrations, for the grid integrations, for the grid frequency control, for grid stability, demand side management. There are aspects, ample scopes of research in battery storage applications. You know, EV is one part of that as a sustainable transportation we are talking about here. But I won't talk about that part because that is another way of my research area in this renewable energy integration, how the battery storage is getting used and as a second life battery of that. So you can see how the battery can be used further as a second life. So this is the fate of the battery. And then further, after again recycling, if again after a couple of years of cycle, then we are having the finally some disposal is required after a long period. But of course, by that time, we should exhaust the entire capacity of the battery through different industry and the stages of applications. And so this is one such say scenario we should also look into. And in India, as you see, that the capacity required for the storage in coming 10-15 years, keeping the growth of the electric vehicles and the renewable energy integration, because the solar is also a huge interest in as per the new policies to integrate gigawatt scale of power in the existing power grids. So battery storage in a large scale, we should integrate also whenever it will be there after the first life. So we should also think of that. And then, so far, if you can see, we are talking about the electric vehicles only, means under running conditions, right? So lithium batteries were the superior most as of now. But if we talk about the EV charging stations, I will take a few slides here to understand, to let you know about what's happening in the EV charging stations. Means whenever we are talking about electric vehicles, definitely we have to use the charging stations to charge the batteries, because residential charging stations can be possible for two-wheeler bikes and the three-wheeler auto rickshaws, e-rickshaws in the rural areas and in small urban areas. But for when you are talking about the lakhs of vehicles in the market, then definitely EV charging stations like in petrol pumps we have. So the petrol pumps we have frequently setup is there. So like that, the EV charging stations are also matter of fact that we have to consider. As a growth of, we should invest money, and the startup companies and of course the existing companies like big players, giants like Tata Power, they are also focusing on now by collaboration with government some EV charging stations. And see the global outlook as we have seen the EVs. Similarly, EV charging station also, the global outlook is there. See the ratio, it is the typical thing, I try to concentrate on that. Ratio of public charging stations per EV stock by country-wise till 2021. EV stock means per country EV stock and its corresponding public charging stations available. You see, Korea, China, Chile, Indonesia, they are having a ratio accordingly. It is not a number, it is a ratio. But you see, where is India now? And you see the target that we have in 2035, 32, in around that, 2040. See the target. And at present, a ratio of, say, it is EVAC. What does it mean? EVAC means electric vehicle supply equipments, or you can say the support equipments, means charging station, charging infrastructure of electric vehicles, so that we can run it smoothly for upcoming 10-20 years. So to meet that demand of growth of electric vehicles, as the price is getting reduced of EVs compared to 10 years back what it was, and the Indian companies also are now producing, as you know, if you have seen the internet, there are a lot of companies, our current companies, your vehicle automobile sectors, they are working on those, they are say in the market, they are contributing, they are coming to the market of EVs in a bigger way. So for that we need to have a charging stations also in parallel to the growth of EV. So for that 10% is the at present status. So definitely it has to have a growth is required. So as per 21, the 10%, even less than 10% of the ratio, if you go for the ratio, means the EV stock and definitely public charging stations. So that is the 10%. So a lot of public charging stations in a bigger way we should need in the coming 10 years. That growth is also required. So it is a glimpse of I would talk about the Indian companies to encourage you that Tata Power is offering EV charging stations in Pune and other sectors in Gurgaon, Noida, of course in South India also. And slowly it will come to other eastern zones also whenever the EV will also be increasing in numbers in coming say 5 to 10 years. And recently Tata Power has tied up with, it is a July 2021 report, says that with the HPCL, Hindustan Petroleum Corporation Limited, HPCL, they have tied up or MOU with installing the EV charging stations along with the petrol pumps. So that is a very much important required, because along with the whenever EV number will be increasing, so we have to install at least a few distance. We have to maintain those charging stations also to be installed in coming few years. So keeping that thing in mind, you see there are charging port, and behind that there is a scene. I will tell you what is happening. Types of EV charging stations based on grid connectivity. That is there are 4 categories of normally grid connectivity. One is only grid connected, means only our outlets, and of course the grid connection, mostly whatever we say about renewable energy, now still 85% of the energy is supplied is coal fired. So that is a majority still, but in coming 10 to 15 years we are almost going rapid growth, exponential growth in the field of renewable energy and solar wind integration, to meet the 175 gigawatt of solar and wind and biomass in coming say 2025. So that is a big target that we have set in our country. And sometimes grid too, as I said, to promote that grid plus renewable energy, mostly solar and wind in our country, keeping the geographical situation in mind. And then another portion is grid, renewable energy and energy storage. What is the batteries and fuel cells supercapacitor for the fast charging? We will talk about the batteries. So far it is established, because supercapacitors are still in research. They have some self-discharge problem, and fuel cells are also need be set up and also very costly compared to the batteries. So it is still under research, not in commercialized, but batteries are well established as of now. And then one is a standalone mode, that is a off-grid system, where the renewable and energy storage, that is the upcoming buzzword of our thing, is the off-grid system, where the standalone mode we can allow the renewable energy along with the battery storage to have a sustainable transportation, where the coal-fired power plants, power generation, that energy we should use as less as possible in the coming years to promote the sustainable energy development. Because off-grid, this is the most important say outlook of our focus of our coming days. And of course, to have a say year around, because the renewable sources are not that much say consistent in generation, they depend on the environmental aspects. So grid has to be integrated whenever required, okay, in the urban areas. But in rural areas, in rural India, in rural sectors, grid is not stable. In that case, renewable energy with storage is a possible solution to charge the electric vehicles. And here's the general layout. As you can see, the renewable energy system sometimes coming through off-grid and on-grid, and the battery storage takes power bidirectional. You see the direction bidirectional is off-grid to battery, and sometimes means through solar or renewable energy. Then from the grid also you can take the charge, and sometimes you have to discharge also. So off-grid system, it discharges to the battery, to the vehicle basically, and V2G sometimes also. There is another aspect of vehicle to grid. I won't talk about that one. That is another aspect of research. And of course, different areas where you can talk about in the industries where the vehicle to grid, sometimes in the parking zone, we're also maintaining the vehicle to grid. Vehicle as a, when it is not actually not running in that mode, we can charge as well as we can discharge also to the grid. There is a balancing of say grid voltage. And you see basic charging infrastructure, what is needed, because batteries, I will come here for a specific batteries for charging stations. That is residential charging with AC supply that we normally have for electric bikes and three-wheelers. Then the workplace and public charging stations. Level 2, then fast charging stations with a dedicated charging stations, means where like petrol pumps. We have. So dedicated charging stations will be there where the fast charging, so hundreds of ampere of charging parallelly to say 10 to 15 vehicles can be charged parallelly. So those are the dedicated charging infrastructure that we need if we want to really growth of the electric vehicles in coming 10 years. These are the challenges. So talk about the infrastructure in level 1. There are levels of charging, means semi-fast, fast, ultra-fast, as I said in the previous slide. I won't talk about the details here because the time is short, but I would like to focus on the batteries for the charging stations. See, this is another interesting thing. That is a lithium-ion battery. So far, we are satisfied with the performance in the EVs. But for the charging stations, when we are talking about the renewable energy integrations, then the life cycle is a matter of concern. Where this is a special type of battery, which is called a vanadium redox flow battery, which we should keep in mind in the upcoming days, where already European countries have started with renewable energy sectors, wind and solar, where the large-scale wind and solar, they have to integrate with such a source for the grid balancing, for voltage balancing, for of course the demand side management, those areas. We should cater with this battery storage. That terms might not be known to you, but these are the interesting things. If you note those and search in internet with the keywords, you will get the proper flavor of those things, what I'm talking about. And see the cycle life, this is most important part, 13,000 plus with 50% depth of discharge means partial discharge, and full discharge if we continue for a time, then 8,000 discharge, 8,000 cycles you can allow. Means almost it is close to the say 12 to 13 years, it is estimated so far. So it is much higher than the lithium-ion battery cycle life. And of course, the for the charging station, that is why, see, the cycle life can be even made longer by remixing the electrolytes. So there is a possibility of remixing, which other batteries do not have. It is a specific property. These batteries, I will show you what is actually it, how it looks like. Okay. And as of now, the cost is still high compared to the lithium batteries, but of course, because it is a rare earth material, vanadium is nowadays the power plants, and one more source of vanadium redox batteries, the vanadium element is source is fly ash. So for the ash ponds that we have from the thermal power plants all over the world, and of course in our country, existing plants, that is a big source of fly ash, is a source of vanadium element, but the processing cost is very important, that we are so far we are procuring from the abroad, but now with the time we have to also think of this vanadium extraction of vanadium from the fly ash content, because we have huge source of fly ash ponds and all, disposal of ash. So from the thermal power plants, right? So this lithium-ion battery is suitable for fast charging with relatively low cost as of now. All we are using for fast charging, but when you are talking about the green energy revolution, then renewable energy will come in the picture in a bigger way. For that case, for very long life cycle, we should use this kind of batteries also. Because here, why very long life cycle? Because it has a specific property of, we can scale, we can distinguish the power and energy capacity by some means. This is a schematic of the system, which is a vanadium battery. See, it is a stack of the battery. Sorry. Then the two tanks are there. See, this kind of battery you have not seen as of now. So this is a special type of battery which is having two small micro pumps and two electrolyte tanks are there. In other batteries, what happens? You have seen the Google images, of course, in the internet, that is a compact design. But here, the design is not compact. It is having two tanks, separate tanks. Through pumps, the electrolyte is circulated in the stack. And as a result, the charge discharge takes place by exchanging vanadium ions. Okay. So, it is the charge discharge reactions are there. We won't talk about the chemical part here, but you should talk about the interfacing part, the electrical electronics engineers. That is a typical charging infrastructure of VRFB system. It is a typical schematic of a VRFB storage with a solar PV source. Mostly will concentrate more on the solar. See the solar PV source, and I'll just roughly go through this for an idea. There is DC-DC converter is required in between. From there, the stack is required. VRFB stack, there is a vanadium battery stack. We should charge and discharge, and talk about this pump also, because the pump this pump we have to control, because this pump will allow the flow rate, the electrolyte flow inside the battery, because this pump will be control the flow of electrolyte inside the battery, which will in turn control the reaction inside the battery, and ultimately charging discharging will be controlled by the pump. So pump is the main controller of the system performance when you talk about this particular battery. But this kind of pumps you will not see in case of other batteries. So that is one problem, that this battery cannot be used for electric vehicle directly. Why? Because it is having more space it requires. It is having a bigger space. Energy density is low. That is the disadvantage of this battery. But keeping in mind the charging station, so stationary charging, and keeping in mind the promotion of the renewable energy sources in our country point of view, so we should think of this battery storage also in the upcoming 5 to 10 years as a charging station battery storage. So lithium-ion battery is used for the electric vehicles aspect because of its portability and its high energy density, with the protections that I have talked about to mitigate those challenges. And then for a new alternate of these lithium-ion batteries for the charging stations, there is vanadium redox battery storage can be used also as a charging stations, keeping in mind the highest cycle life, of course, and you can say the solar compatibility. So this is the typical hardware circuit. See, this is the battery I would like to talk about. There is a 1 kilowatt battery storage which will discharge for 6 hours. Okay, a small laboratory scale battery storage. 2 tanks are there, as I said. It is a bigger structure. So compared to a 1 kilowatt lithium-ion battery, structure is bigger. That is why it is not used for the electric vehicles. But of course, it is used for the stationary storages with renewables. When we will talk about the renewable energy sectors for the electric vehicle charging stations, means renewable powered charging stations. To promote sustainable development, we need this kind of batteries. And this is a power electronic circuit board which we have designed earlier 2-3 years back for the such kind of VRFB interfacing from solar. It is a DC-DC stage converter. As you know, the solar is DC power, solar energy, and if you want to charge it properly, maintaining the battery constraints, not like lithium-ion batteries, because it has exposed structure. So heat generation is bit less compared to the lithium-ion batteries. That is the most important part. So in bigger scale, we can use it in an efficient way. And see, this is some results I would like to show for an encouragement that some simulation work can be done. As I said, in console, you can go for some simulation. In MATLAB, you can go for some simulation study. You can design a charge controller in MATLAB simulating environment. For the solar power plants are already there in the latest version of the MATLABs. You can take those things and you can customize as per your own. But this model, you can see the papers also. You can model this battery storage. You can charge it and see the behavior under different conditions in MATLAB also. Because in pandemic situation, in this online mode, you cannot use the hardware circuits directly, but you have to have the flavor through this say software simulation mode. So you should know before you pass out from your graduation, you should know at least the software in a say proficient manner, so that you face some advancement of the technology in this field of renewable energy. And see, this is a thermal management. Although we have talked about it, does not need thermal management, unlike lithium-ion batteries. But there is a one problem that as we know that the pump is there, so you can control the pump only by some means, and definitely by some variable frequency drive it is called. In the power electronics and drives you will study this VFD. In the lab also, perhaps in machine labs you have seen the VFD based machine control, speed control. So that is nothing but this pump is including nothing but a AC pump, single phase AC pump, small pump. And this pump can be controlled by a VFD, dedicated VFD, and this pump control will lead to the your flow rate control, which will be ultimately flow rate control means reaction rate control, because it is dealing with the chemical reactions, and chemical reaction will lead to the charging discharging control, because in the battery chemical reaction takes place and charging discharging starts. I will not go to the detail of chemical things now. And that charging discharging control means ultimately the power loss also gets controlled. So power loss in terms of heat. So the heat can be controlled by flow rate. Flow rate is nothing but in this battery particularly, you see in this battery, through these two pumps, this flow rate is a flow from this tank to this stack. Blue one is the stack. Okay, if you can see, and the tank to this stack also, both side plus and minus, we have ionized liquid flow here, vanadium with the acidic medium, and then we flow that. So this flow rate not only controls the your charge process, but also it controls the heat generation inside the stack, because this extracts the heat from the stack to the tank in terms of the flow, because that flow depends on the as a coolant as well, not only a charge carrier. That is the advantage of this battery over lithium-ion batteries for the charging station point of view. Okay, so this is the line. Unlike lithium batteries, VRFB storage does not need additional costly thermal management system. Electrolyte flow is dynamically controlled based on a closed loop pump controller to control the temperature within safe limit. And this is the flow rate, as I said, flow rate change with time, and temperature you see can be controlled. Uncontrolled flow rate, rate 1, reaches to 40, and half time the battery will stop, because battery controller will stop the battery exceeding temperature, because the thermal shutdown will be there. If you maintain the flow rate like this, with time you can see the state of charge can be full, 90%. Black one is the controlled temperature within the limit. As I said, for lithium-ion batteries also same thing, but arrangement is less for required, so cost is also less in the your lithium batteries, unlike that. So in a nutshell, now it's come to towards an end. I am taking still 10 more minutes. Sorry for that, because there are a lot of things to discuss. Still, we have less time for this 1 hour to discuss all these things. But anyway, try to give you some glimpse of that, what is going on. And you see, the outcome is batteries are now going to be the key players of this sustainable transportation, and focusing on the government policies. As you know, the demand, we should have indigenous battery factories, which is still not now in our countries, but Exide and other companies are now tying up with Lakeland's different companies which to manufacture lithium-ion batteries but of course it is still in assembly mode. So cost is still high, and the EV charging stations, more renewable and solar wind-based installations are required to promote the reduced carbon emission. As we said, it is our main motto of the environmental aspects. We should integrate more renewable sources. As a result, whenever we will talk about renewable sources, then the more longer life cycle battery we should recommend. For that, vanadium redox flow battery is such kind of battery which is having a highest cycle life as of now compared to other batteries. So that can be also chosen for the EV charging stations point of view. So these are the things from my end to convey to you. Thank you very much. Thank you for the patience, and I took a lot of time. Very sorry, but anyway, we should promote the Go Green projects, and you can reach me in this email ID. You can note it. And later on, you can also have some doubts if you have, or interest. Those who are, I believe that few of you will get the interest on electric vehicles and the battery storages after this session. And I would now expect some questions also from you, although we don't have much time in our hand, but still, can we have some questions, organizers, although I am late? Yeah, thank you.
Thank you so much, sir, for taking out time.
Yeah.
From taking out time from a busy schedule and being present with us in this webinar. Kindly, the attendance link has been given in the chat box. Please fill it up to get your certificates, and as well as fill the feedback form too.
Make sure you filled up both the attendance forms to get your respective certificates. Thank you.
Students, do you have any questions?
Okay, so if the participants have any questions,
Yes,
they can
please,
write
I
it
would
down
appreciate
in the chat box below and we'll read them out to sir. Feel free to interact. Absolutely.
You can unmute also your side if you are feeling that. You can unmute and say something. I think either they have understood everything or they have understood nothing anyway. I don't know what is the outcome.
Don't feel shy. If you have any questions,
Please
you
ask me the
can interact
questions.
with us freely. You can ask sir any questions you want.
You can write it on the
Dr.
chat box as
Bhattacharjee.
well.
Yeah, please.
May I ask questions?
Yes, please.
Okay.
Please continue. Yeah.
So thank you very much. Your wonderful speech, almost covering all the aspects of storage batteries for e-transportation. Thank you very much. I have a small question regarding
Yes,
the charging modes of the lithium-ion battery.
Yes.
Does it take any kind of trickle charging at any
Yes,
place
correct.
of charging?
Correct. Because there are two ways. One is sometimes trickle charging is required. What I showed in that soft charging, if you can recall, in the soft charging also almost C10 or C by 10, you can say C by 20, we can allow a small current until that your voltage reaches to some say percentage of the total voltage of the capacity voltage. You can allow as a trickle charging, and of course towards the end also you can allow for some more time. Because there are some 5-stage charging you're established in the market in the name of soft charging, bulk charging, then pulse charging, then trickle charging. So these are the aspects of battery charging. So trickle charging, of course, it is required for the ensuring say complete charging. Sometimes high charging current is not always recommended for the batteries.
Okay. Because the lithium-ion batteries are very vulnerable for overcharging, isn't it?
Yeah, correct.
It's very much vulnerable to be explored. There are many accidents due to this exploration. And one more thing I want to mention here that from your lecture, it is very much understood that in the decade ahead, so we have large options. Okay, so huge prospects for these storage batteries and e-vehicles. So our student must equip themselves with these storage batteries and e-transportation.
Correct.
I think we don't have any understanding on that, because in most of the undergraduate curriculum we don't have the storage batteries, isn't it? So
correct.
So so there should be some sort of encouragement for students as well as from the institutes also. So there should be some encouragement so that this type of course can be included in our curriculum. Okay, so that's all.
Correct. Elective subjects can also be introduced if it is autonomy. Yeah. Sometimes if the university gets autonomy or college gets autonomy, then some electric vehicle or battery storage, energy storage systems can also be introduced in the elective papers for the 3rd year, 4th year students. It can be managed. So we can, the institute can also think of that. Correct. To promote the students a good idea on the upcoming things. What we have discussed, because in 1 hour it is difficult to give you a whole lot of things.
Yes.
Still, the idea I wanted to convey so that it can be encouraged. Yeah.
Okay, thank you very much.
So are there any more questions from any participants?
Students, I would love to have some questions from students, please. Okay, some question is there in chat box.
So Jyotirmoy Kaur asks, sir, will ores of battery minerals suffice the growing need of EVs in future?
Of course, see, that is as your professor also, Professor T.K. Datta also raised the point at the beginning, is that this okay, fine, it's fine, we'll manage. So this minerals of the batteries, as we said, that minerals there is a scarcity of the minerals. Of course, the process, even though minerals is there, but the process from the minerals to this to extract those elements and then finally to manufacture the battery, that involves a lot of cost. In the especially lithium-ion batteries and what I was talking about the vanadium batteries, that's why they are still in India. We could not manage to establish those in-house extraction centers. We are still bringing from outside. But of course, with time, the process is still, it is a developmental process. Every technology has to develop over decades, over years. So we cannot say at this point that it is a bottleneck. But of course, since last 20 years, that the huge growth is there exponentially. Some data also I shared with you, how the battery storage growth, how the EV growth is there globally. So keeping that thing in mind, definitely the investment is being done. More emphasis from the government policies are there to invest more money in the energy sectors, to promote renewable energy and energy storage as a solution for the upcoming power sectors as well as the electric vehicle sectors. So these will involve definitely lower cost of say investment, and in the coming 10-15 years we will have also in our country indigenous plants to cater these problems. Yeah. Any more questions, please, related to the electric vehicle or battery storages or any other relevant questions? Sorry. Okay, so I think.
So I'm guessing no one has any more questions here.
Okay. So any faculty also, if it is there, we can, because sometimes students get shy to ask questions, so they can also know through our faculty members, right? So if possible, then also I would be happy to interact. If anyone is there, I don't know. Actually, I took a lot of time at the end because I thought maybe to finish it by 6, but anyway, I finished it at 6:20. So anyway, maybe people are not that much. People got tired listening to those things. Maybe.
So I'm guessing there are no more questions.
Yeah, I guess.
So, thank you, sir. Now I would like to call upon Nirban Chakraborty sir, member of IET YPS section of Kolkata local network, to give out the vote of thanks.
Thank you, Shreya and Shomo, for the nice conduction of the program, and
welcome, sir.
And great thank you to Dr. Ankur Bhattacharjee sir for giving us this time and giving us this nice speech. Starting from the scratches, that means the first starting point was the most important thing, that why we need to focus on the storage and electric vehicle, all those things, so that the students can understand that why the researchers need to focus on that area, and then give a very good and from the basic description that the undergraduate students can understand from his speech. Thank you, sir, for this great nice presentation. And I think though the students don't ask so much questions, but I still think they have gathered a lot more knowledge by seeing your lecture throughout this platform for the last 1 hour, because it was a nice presentation and I also learned lots of things from your presentation. And we hope that we will have more such kind of interaction in future. And as a vote of thanks from this IET student chapter and IET YPS section, we want to thank you to present you this plaque for this honorarium for presenting this webinar on the role of battery storage towards the sustainable transportation challenges and mitigation. Thank you, sir. Thank you.
Thank you very much. Yeah, thank you, Professor Nirvan, for this wonderful, you can say, vote of thanks. And you have, in a nutshell, also you have you have focused those things for the students. And yes, I also agree that I too agree for the undergraduate students, we should not expect real-time, gathering of knowledge for these new areas or emerging areas. But I am hopeful that they will contact you and the professors, those who are there, and also, if possible, then me also, because I have given my email ID there at the end of the slides. If they have some query regarding the research interest or any project interest based on the electric vehicles in this scenario, as much as possible in the online or simulation mode, if they can do, I'll be happy to interact with them and to collaborate with them. So that is from my point of view. Thank you, and IET, of course, I should thank IET as a platform for giving me this opportunity to share something in front of you, the electronics engineers, undergraduate students, to give you such flavor of the upcoming technologies, which you should, many of you will maybe taking this opportunity in the coming years. Nobody knows. So let's see. Let's hope for the best. Thank you from my end. Yeah.
Thank you, sir. Thank you once again. So, sir will share the PPT with us, and then we will share the PPT.
Yes, of course. Yes.
With the students for their reference. So, thank you, students, and thank you all the dignitaries present here. Thank you, Shushanta sir, for be present there throughout the seminar and give us the time. And also thank to all the students and also to the speaker. Thank you. Shreya and Shomo, you can conclude the session. Thank you.